Another way of measuring the concentration of a solution is by measuring the molality. Molality, which is symbolized by a lowercase m, is the moles of solute divided by the kilogram of solvent. Why do we have two different forms of concentration, molarity versus molality? Molality is used when temperature is changing. And the reason why we have to use molality when the temperature change is that temperature will change the volume, so we can't use molarity because molarity is moles of solute per liter of solution. So if you change temperature, your volume of your solution, your liters of solution will change. So that's why we have two, molarity and molality. Alright, so in this first example, very easy example, it says we have 3 moles of sodium chloride and 1.5 kilograms of water, and we're looking for the molality. Don't read these questions too quickly or you might see molarity instead of molality, so do try and take your time with that. It's important to know which one is a solute and which one is a solvent. Well, in this problem, even though it tells us moles and kilograms, it also says that sodium chloride is dissolved. So the thing being dissolved is called the solute, and the thing doing the dissolving is the solvent. Now for any problem, anytime you have water, water is always going to be the solvent. I'm sorry, we didn't actually answer the question. So molality is equal to moles divided by kilograms. So then we would have 2.0 moles per kilogram. But moles per kilogram means molality, so you could say 2.0 molality with the little m there. Alright, in this question, we have 25 grams of NaCl dissolved in 2 grams of water, and again we're looking for the molality. So here we have sodium chloride again is dissolved, so that is my solute. Water, of course, is my solvent. So my solute, I need moles. So we'll say 25 grams of NaCl, and we'll convert it to moles. 1 mole of NaCl is the molar mass, which is 58.5 grams, sodium plus chlorine. And we get 0.427 moles. I guess we only really need 2 significant figures, so we'll say 4.3 moles. And so our solvent is already in kilograms, so we'll just need to do molality is equal to moles divided by kilograms. We need 2 significant figures, so we'll say 0.22 molal. Alright, here we have, we're looking for molality, and we're given 15 grams of I2 dissolved in 500 grams of alcohol. So I2 is dissolved, that would be my solute, in my solvent. Another way that I know alcohol is a solvent is because the solvent is always the larger amount. So 500 is larger than 15. So my solute, my 15 grams, I need to convert to moles. Iodine is a diatomic, so we want to make sure we use the molar mass twice. And we have 0.059 moles of I2. Now my solvent has to be in kilograms. King Henry died unusually drinking chocolate milk. We're going from grams to kilograms. So we're going to go back 1, 2, 3 spaces. So this is 0.500 kilograms. So the molality is 0.059 moles divided by 0.500 kilograms. we need two significant figures, so this would be 0.12 molal. Now you're not always going to be looking for molality. Sometimes you might want to know how much of the solvent or the solute you needed. So one more problem here. We have our molality given to us. Make sure you recognize that that little m is molality. We have 750 grams of calcium chloride, carbon tetrachloride, and we're looking for grams of iodine. So iodine added to, so iodine is my solute. That means the carbon tetrachloride is my solvent. 750 grams is an awful large number, so that large number is also telling me that that is my solvent. My solvent has to be in kilograms, so King Henry died unusually drinking chocolate milk. We're going to go from liters to grams to kilograms. So we're going to move to the left 3 spaces. So I have my molality is equal to moles divided by kilograms. So in order to find my grams of my solute, I have to solve for moles of my solute and then convert back to grams. So we'll multiply both sides, by 0.750 kilograms. And we have 0.015 moles. And then we'll need to convert that to grams. So 1 mole of iodine. Don't forget iodine is a diatomic, so we need to do the molar mass twice, 253.8. For 2 sig figs, we get 3.8 grams of I2.